Thanks, Dr. Nealon. First off, I just wanted to thank Dr. Nealon. I don't think I would have actually finished this semester if he didn't push me to do it. I was a little reluctant, but he kept pushing me and ended up doing it. So I think this presentation is a little bit different. It's going to be a little bit more scientific. I'm not going to read it, this title, since you just heard it, but just to jump right in. This guy in this video, he's changing the time of day from early morning to late at night to bring out the shadows. And I have a little photo of what he's trying to do. And what he's trying to do is he's trying to highlight these ridges and these valleys in this forest, because he's trying to offer tips on how to locate Bigfoot habitats. And this is really important citizen science. So, and especially with maps. So the thing is, on the visual perception, you're trying to pick out this edge. Ooh, I knew I was going to have, my mouse is a little jumpy sometimes. And what he wanted to do is pull out this very hard edge of the shadow, because that's where he thinks that the habitats for Bigfoot is. But they probably are. So some things about maps, we can back up for a second. Let's talk about a couple of things about maps. One, maps are implied science, and we need to know these things to help us identify Bigfoot habitats. Maps also have an element of art. Maps are a simplified representation of the world, and maps involve the map reader performing a task, such as searching the map for one or more objects. In this case, it was the shadows to identify Bigfoot habitats. One issue, though, when people like myself who are map designers rely a little bit too much on their experience and intuition. And what can happen when we do this is, if anyone recognizes this, this is a scene from a movie called Moneyball. There's also a book, and Brad Pitt plays Billy Beane, who's the general manager of the Oakland A's. And he's sitting in with all of his baseball scouts, and they're discussing their prospects for the upcoming draft. And they're talking about these prospects, like the ball explodes off his bat. He's got 5 tools, he's super fast. And Billy Beane the whole time is looking down at his sheets of paper going, and looks up at the guys and goes, but he doesn't hit. He can't hit the curveball. He doesn't get on base. Next. And these guys get very dismissive because they had relied on their experience and intuition to tell him he was a good baseball player. But Billy Beane said, no, the evidence suggests that he's not. So what kind of evidence can we provide for people like myself who are map designers? Well, it turns out, if we believe that maps are actually an exercise in human visual perception, that's pretty easy. We can use theories from visual search, which is a part of psychology, and then also things like the Gestalt principles of perceptual organization. So here we have just kind of the basics of visual search, and we can see the American Psychological Association's definition, and then my version, which is visual search is a process of searching for an object, really amongst other objects. If you look at this little graphic I have here, we see this red circle, and if we call this the target or the object we're looking for, that is the target, right? And all the green circles are the distractors. Now, the time it takes to find this red circle target is the reaction time. And the colors and the shape are all features of those objects, of the distractor and the target. One of the foundational theories in visual search is feature integration theory. And really, the feature integration theory breaks searches down into 2 types, and it's a feature or a conjunction search. Now, in a feature search, targets are distinguished from their distractors by 1 feature. So in here, we see the green circle and the red circles like we saw before. Now, a conjunction search, the distractors have 2 or more shared features. So we see a bunch of features shared between all the distractors. Now, in a feature search, as you add more distractors, the reaction time to find that target stays flat. It stays, and the time does not change. And in visual search, we call this a parallel search. And what happens is we see it and it all happens at one time. With the conjunction search, as you add distractors, the reaction time increases in a linear fashion. So in other words, the conjunction search is harder. And we call that a serial search, because you really have to look at each individual object to find the actual target. A second theory in visual search is attention engagement theory. And this took it a little bit further. What researchers started noticing was that there's not this very dichotomy of searches where it's not just feature or conjunction, and it's not just serial parallel. In fact, it's probably a little bit more of a continuum. So on top of that, intention engagement theory pointed out the fact that when there's similarities between targets and distractors, that also adds to the reaction time. So if you look at our chart here, as the similarities between distractors decreases, we start seeing less parallel searches. The similarities between targets and distractors, we see this less serial. As we get up into the upper quadrant, we see the most serial, really the hardest searches. And you can see this being illustrated right here in these 4 graphics as all the different distractors. Right? Pretty simple, I think, to kind of get that. Now, there are other visual search theories out there, but in the context of what I'm going to talk about as we move on, that's really what I wanted to get through. It's just some of the basics around it. And the real ideal here is that there is no difference between serial and parallel, that really all searches are probably serial, just some are a little bit more than others. For map designers, it's surprising to find out that there's very little literature about doing visual search on maps. And that's probably in part to do is that most map designers, or cartographers, as I'd like to call them, have a very low exposure to psychology. I mean, it's really, cartography is usually a part of geography, so psychology is not usually some of the courses that geographers are taking. Second, the application of visual search theory doesn't really feel achievable. And by that, I mean, when you're dealing with a map and it's a representation of the world, we have very little control over where these objects on the map live and where they are at, or even what they look like. We have no control over it. So it feels very unachievable to use the techniques of circles and squares and P's, Q's, and T's that we see in some of the visual search research. One researcher did start diving into visual search on maps, and Robert Lloyd out of University of South Carolina, he took some aerial photography or satellite imagery and looked at several different land use types. In this case, stores and schools, churches, and farmhouses. He believed that stores and schools looked very similar, and that the churches and farmhouses, and those would be the distractors that look similar. So what he did is he distributed these on the map and used one of them, let's say a school, as the target, and asked people to find it on top of an actual aerial photography of trees and a dark gray background. What he found was reaction times are the fastest when targets are unlike distractors. Well, that's just what we heard a little bit ago. And again, reaction times increase as similarity between the targets and distractors increase. He also found that reaction times are slowest when distractors are similar to the targets and dissimilar to each other. So those same 3 graphics and figures that we saw with attention engagement theory kind of explain exactly what he was talking about. The fourth thing he found that I didn't really list here is he also placed all of the distractors in one quadrant of the map. So let's say he put all of the distractors in the lower left-hand corner and then put the target in the upper right-hand corner. What he found was the reaction time was actually faster no matter how many distractors he did. So the location and the organization played an important factor. And this is where Gestalt principles come in. So the Gestalt principles are perceptual organizational, a set of laws that describe that. And they were created by a group of German psychologists in the early 1900s. The foundational piece of Gestalt is this law of prognose, which states psychological organization will always be as good as the prevailing conditions allow. A lot of people just say it's the simplest form. Gestalt psychologists with law of prognose like to point to how oil will form in little spheres when it's put into water as an example of how the simplest form is done. So those same principles that govern how oil will go into the little spheres in water, they came up with a set of principles that can govern that too. The first one is the principle of proximity. So basically this states as objects get closer together, they're more likely to appear as grouped together. So we see these 6 light gray dots, they seem to look like three groups of two, right? And then we have the principle of similarity, which we have these two groups of light gray and dark gray that seem grouped together because of their color. With the principle of closure, we tend to see things as wholes, even when they don't exist, because we're trying to create the simplest form again, while prognos. And here we see 4 circles in 1 square on top of the circles, even though none of these shapes individually actually exist in the figure. And then finally, the principle of good continuation. We see these lines continue across each other instead of in little v's. And even if we separate these lines out into these circles, the same thing continues to happen. One of the things with principle of good continuation is the most important factor is the less sharp angles there are, the more likely we are to see it to work in continuation. One thing about these principles are that they lack, oh, I'm sorry, let me back up. I was going to jump ahead to the next one. So another part of Gestalt is figure ground. So when we look at these graphics here, what we notice is these symmetrical shapes tend to be the figure, they're popping out in front, and the asymmetrical shapes tend to be in the back, in the ground. So in these two figures on the top, the white on the left side has very symmetrical edges or contours, and that ends up being the figure, and the black is the ground. And then the opposite on the right side happens, where the black has more symmetrical edges. It tends to be the figure. On the bottom, we see kind of a different thing happen, and this is probably a graphic that many of us have seen before, the face and the vase. Now, both edges in this are symmetrical, so what happens is we see this flip-flop. It's harder to determine what's the figure in the ground, and I'm sure most of you are looking at this now and seeing the face and the vase in both of the images. And as I said, the edge between this is called the contour, and that's going to become important as we move ahead. The thing about Gestalt principles are the principles have a big explanatory power. They help explain why we perceive something and why the way it is, why it looks the way it looks. But there's very little empirical evidence of these existing. And that, I mean, with proximity being an exception, proximity is one of the only Gestalt principles where there's a certain distance where things, or people, researchers have found distances in which you start to see things as grouped together. And same with continuation. The main thing with continuation are the sharp angles. So less sharp angles will mean it's more likely to be seen in continuation. Despite the lack of empirical evidence, the important thing about Gestalt principles is not one of them has ever been refuted. No one can refute them, but you can also not prove that they're really there. So it's hard to say that this follows Gestalt principles and this doesn't, because there's no empirical evidence. So interesting, you would think that Gestalt would play a huge role in mapping, but unfortunately it does not. So when you read literature about Gestalt maps, what you see, and I left this page intentionally blank because there's just nothing. And when you do find stuff, it's like, as a cartographer or as a map designer, you should use Gestalt principles, and here they are. But they don't give you any way to actually use them in mapping. When you get to figure ground, there is some research, but it's very limited. But what we know is, if we go back to our first topic, is if mapping is really about that task in searching for objects, then it would make sense that that object should be the figure, and that we should make certain that that figure is easily distinguishable from the background. And in this case, we see 3 base maps which act as the background, and these red splotches as the figure. Now, in a lot of maps, there's all kinds of other things that we put on it that are going to distract us from finding that target of those red splotches. And that's where things get really important. So wrapping some of this literature up that I went through, I wanted to understand what's going on with this. So this is similar to what Lloyd pointed out, that when he organized his map with some things in one quadrant and then the target in another, the reaction times drop. So in these two, if we follow just visual search theory, we would expect both of these figures to have the same exact reaction time. But looking at it, I don't think we really need an experiment to tell us that the red circle being the target is going to be easier on this right figure. And it's because of the way it's organized, right? There's grouping, there's things that are close together that have similar shapes. And in the end, this contour between our target and our distractors is easily discernible, so it's easy to pick it out. One thing to note is this is very unlike a map. In a map, a lot of times our target's going to be on top of our distractors too, which doesn't happen in any of the visual search research. So we really need to start thinking about how we can help map readers do stuff. And more importantly, how can we help our citizen scientists trying to find Bigfoot habitats? Because this is critical for if we're going to advance science. So I decided to do an experiment that took a look at the influence of Gestalt principles on reaction time when we're doing visual search, especially on maps. So some of you on the call, you might have done my experiment. If you did, thank you very much. That's always a big help to get that help. So what I wanted to talk about is what the experiment entailed. So what I did is I took 2 targets. It's listed 3, but it's really 2 targets because in all visual search, you have a lack of target condition. And I did one that's less Gestalt and one that's Gestalt. And we'll talk in more detail about these in a second. I created 2 distractor types, one that's random that mimics what you would see if you were doing remote sensing and got a bunch of random noise. And then a clustered where I wanted to mimic a distractor that would start having similarities between my target and also resembled things like clouds or other things that you would get when you were doing remote sensing. And the last part of this is I wanted to make sure I included base maps because base maps are a critical part of mapping. I don't think any of us encounter maps whether we're getting directions on Google or anything else where we don't have it. And I used 4 different base maps. So in all, I did 4 trials and they were all randomized, just so you kind of get a background of the experiment. So in specifics with the target, I had 2 targets. One was Gestalt. This is my target that I felt met Gestalt principles best between these 2, and then one that followed a little bit less. What you can notice about it is both targets consist of objects in a linear alignment. And if you look at good continuation, it's really people tend to perceive objects in alignment as forming smooth, unbreaking contours, especially when there's less sharp edges. And if we look at the 2, our Gestalt target actually has less sharp edges than our less Gestalt target. The second part, with proximity, that shapes that are closer together will appear to be together greater over ones that are further apart. And our Gestalt target definitely is closer than our less Gestalt, then I've actually measured that. So I know that that's true. To ensure that people didn't learn the location of the target was placed randomly at 50 different locations, and it just depended on which one you randomly got. You answered yes or no to the target being there. So for my distractors, I had 2 different types. I had that random, as I said before, and then this cluster. And things to note about the random is that as you move from this all high, medium, low, what we're really doing is getting number of distractors. So we're having the most distractors here to the least distractors here. So they're somewhat categorical, but they're also providing number of distractors. With our clustered, where we're trying to match and get more similarities with our targets, it's under the same pretense where we have from large to medium to small, which shows less distractors to more distractors, and the same from smooth to rough. So as we go from smooth to rough, we're increasing the number of distractors also. So I call this distractor-ish because it's not necessarily a distractor, but it's a crucial part of mapping. I don't feel like I would be being realistic, and that's one of the things I try to do when I do experiments with mapping is I try to keep it as realistic as possible and minimize my manipulation. So I just added base maps straight from a software company called Esri, one with no base map and then a dark aerial imagery and streets. And these are very typical base maps that we use in mapping. So I just want to go over some interesting numbers because I think this is always kind of interesting to see when you talk about experiments. I had over 300 participants when I wrote everything up. I think there was even more since I wrote it up. There's over 210 participants completed at least half, which resulted in 116,000 different conditions being reported. Then one interesting little tidbit, in order to make the website work, I had to create the maps beforehand so they would be cached. And that was 167,238 maps. So that's a lot of maps. And it actually had to run over 3 days on a computer to create all the maps. So hypothesis. First off, the less Gestalt target will have higher reaction times over the Gestalt target. Reaction, and this is the rest is going to be taken directly from Lloyd, because I really feel like Lloyd is a good mix of taking mapping and intention engagement theory, which I think is a visual search theory that fits best. And the thing to note, and I won't read them to you because I find reading the slides to be somewhat boring, so you can read them, and I'm sure you're reading them as I talk, is with the less Gestalt target in the Gestalt target, that the Gestalt target should have the impact with the fourth one of overcoming some of the difficulty. if Gestalt principles are able to affect reaction time. So jumping into some results, the first thing you'll notice is that there's some missing data, but it's actually not missing. So what happens is when you have this all condition, the map is completely covered. So if I displayed that, what you would have seen would have been 4 maps exactly the same. So I removed the all condition, but an accident happened, and I accidentally removed the less Gestalt and all condition. So I did miss one data point, but that's not too big of a deal. So looking at these results in context of visual search is the thing to look at is the colors are always going to be the same. The blue is going to be Gestalt, the orange is going to be less Gestalt, and the green is just there was no target. We notice that there's differences between the less Gestalt and less Gestalt, right? And this is statistically significant difference, except for this very low condition and the medium and the dark. The second thing to notice is, for the most part, the Gestalt targets produced a more flat or less serial reaction time, as opposed to the less Gestalt target. I'm going to keep getting those words mixed up. It's hard to say. It's like a tongue twister, which is interesting. So that's starting to prove the idea that I had before this. The other part to notice is that the streets and imagery base map, its fastest times are the slowest times in the none and dark base map. Now, looking at the cluster, is what we notice is a more pronounced of all the things I just talked about, right? The Gestalt target, and this is where we should see this, right? If it's true that the less Gestalt target, that Gestalt principles have an effect on reaction times, this is what I wanted to see, and it kind of happened. We see a much less serial, a more flat reaction time for the Gestalt target, and as the number of distractors are really increasing with the less Gestalt target, we see even greater and more linear reaction time curves. Another thing to notice is that same pattern of the streets and imagery's fastest times are really kind of the slowest times in the none and dark. And again, the only time there's statistical significance to being equal in reaction time is at these lowest conditions, at the fewest number of distractors, which we should expect to have that. So did the less Gestalt target have higher reaction times of the Gestalt target? Yes, in all cases we did. I took some statistics of just looking overall, and no matter what I do, that remains true. So the less Gestalt target did have reaction times. It's probably a little bit harder with the less Gestalt. If we look at reaction times will be fastest when targets are unlike distractors. We can see that this did happen. And the things I want to start pointing out in this is, in this first case where reaction time should be fastest, is how easy it is to see the contours between the targets and the distractors. It's very clear that break. And that's part of the reason the reaction times were more likely to be happening as quick as they did. As we increase the similarity between the targets and the distractors, the reaction time should have also increased. And we did see that, and I showed you that in those graphs. But again, we start seeing as the reaction time started increasing, it's getting harder to start making out the difference between those contours, especially with the less Gestalt. You can start seeing, especially in this rough edged medium cluster, that you can start seeing it starts getting really hard to see that edge. As we get into the hardest or the slowest reaction times, this is when the distractors are similar to the targets and dissimilar to each other. It becomes even more pronounced. These contours are really difficult to see, and it's even harder when we get to the less Gestalt. And there was pretty big differences in the reaction time with this less Gestalt. So one of the questions I had after seeing this is it the base map? So when you look at these four kind of maps here, what you notice is that the only thing different between the maps on the top and the maps on the bottom is the base map. And there is a difference, right? I mean, clearly you can see that. You can see that with the reaction times that I've posted on the edges here and here. But you can also see how much easier it is to see that contour as opposed to when we have a streets background. You can barely see it, right? But what I want to point out is that, is it really the base map? It kind of is, but it's really about the contour. So looking at the exact same distractors, what we notice if we look at some of our maps where we move that target, remember I talked about randomizing the location of the target. In these top two maps, the target is in a slightly lower location than in this one, in the bottom two maps. And if you look at the less Gestalt on here, it's very difficult to see those contours. Or on the bottom, it's very difficult, but a lot easier on the two top maps. And it's very clear on the reaction times, which are statistically different, statistically significant and different. So those were kind of my conclusions. I like to do things where I'm an applied scientist. That's what I do for work. I make maps, I write software, I design software. And one of the things with a lot of research is there's never really an applied takeaway. Like I don't know how to apply a lot of the research, which was some of the conundrum with not having a lot of research, this visual search research and the Gestalt principles are not a map because it's hard to figure out what to do with it. So I want to provide that to people on this call that I know are also mappers. And one is, for visual search tasks on maps, improving the figure and the ground separation is critical. To me, that's one of the first things that I got from this, is that we got to be really careful with that. It's still hard to do because sometimes we just don't have control over that. Another thing to know is that if we do have a little bit of control over it, targets that follow Gestalt principles will likely reduce reaction times when the target and distractors are most similar. And that's a good finding to have, but still, we don't always have control. So there is one thing that mappers almost always have control over, and this is the base map. So one thing that we can do as map designers or photographers or building websites with maps on it is we should probably start using these dark base maps or these really single colored hue base maps, and they can come in all different colors, light gray, blue, whatever. The thing to know is how we want to make sure that that base map is as dissimilar from the target as possible. Because as we saw with the dark base map and the street base map with the exact same distractors, the difference in seeing that contour. And if we start our map readers off with seeing that, and then allow them to switch to base maps later, they're going to be more likely to find that target. And it's not just about reaction time. I've included a chart with accuracy, and accuracy is not something that's usually mentioned in visual search. In fact, most visual search, when they do report accuracy, it's usually 92% accuracy and greater. But what we see with our less Gestalt target and our Gestalt target is that it starts dropping below 90% with the street space map. So to me, that's a really important takeaway, and is the base map is really important. So that's what I have. Thanks for listening, and I guess I'm ready for questions.